Hi guys, welcome to my shopping scientifically vlog. My name is Kisha and I'm from 12F. So, the first product that I bought is a nail polish remover and the brand is Happy. And the second product that I bought is a wafer and the brand is Nutella Be Ready. Things you need to do before a lab investigation. First, take off all of your accessories. Second, wear a lab coat and button it up. Third, tie your hair. Fourth, wear a glove. And last, wear a mask. So the first product that I'm going to do the identification test for the functional group will be the nail polish remover. The identification tests are Brady's test and Benedict test. As you can see, there is acetone in the composition list. The most important ketone is acetone, a liquid with a sweetish odor. Acetone is one of the few organic compounds that is infinitely soluble in water. It also dissolves many organic compounds. For this reason, and because of its low boiling point, which makes it easy to remove by evaporation when no longer wanted, it is one of the most important industrial solvents, being used in such products as paints, coatings, and nail polish removers. Nail polish remover contains acetone, and the functional group of acetone is a ketone, which is characterized by the presence of carbonyl group in which the carbon atom is covalently bonded to an oxygen atom and the remaining two bonds are to other carbon atoms or hydrocarbon radicals. First, I use 2,4-DNPH to identify ketone. So for Brady's test, we're gonna use a 2,4-DNPH as a reagent which detects the presence of carbonyl compounds. The carbonyl groups of ketones undergoes a condensation reaction with the 2,4-DNPH. A condensation reaction is a reaction in which two molecules join together and a small molecule is eliminated. The product formed when 2,4-DNPH is added to a solution that contains an aldehyde or ketone is a orange precipitate which can be purified by recrystallization. Second, I'm going to use Benedict reagent to confirm that it is ketone. Next, to confirm that it is ketone, we need to do the Fehling test or Benedict test. A Fehling solution or a Benedict reagent is a blue alkaline solution containing copper-2 ions which act as the oxidizing agent. Ketones do not react with Benedict reagent because they are resistant to their oxidation under the mildly alkaline condition of the test, resulting in no color change from the reagent's initial blue color. To do the Brady's test, I need to use a test tube. First, pour 1 cm cube of a nail polish remover into the test tube. Then, add 2 drops of 2,4-DNPH into the same test tube. You can see that an orange precipitate is formed, which shows that ketone is present. But since an orange precipitate can also mean that an aldehyde is present, we need to do a Benedict test to confirm that it is ketone. First, pour 1 cm cube of a nail polish remover into another test tube. Then add several drops of Benedict reagent into the same test tube, enough to observe the color. Put the test tube into a hot water bath and wait for a few minutes while observing the color. After 2 minutes, it doesn't change color and remains blue. This confirms that it is ketone. Next, I'm going to do the identification test for the functional group in Nutella Be Ready wafer. The identification test is Benedict test. As you can see, there is sugar in the composition list. One of glucose's important chemical properties is that it acts as a reducing sugar. Glucose is capable of donating electrons to other molecules during a chemical reaction, thereby reducing them. This reducing ability is due to the presence of a free aldehyde group in the open chain form of the glucose. Glucose open chain structure is a straight chain of 6 carbon atoms, with carbon atom number 1 having an aldehyde group and the remaining carbons each bonded to a hydroxyl group and a hydrogen atom. Nutella Be Ready contains significant amounts of sugar derived from sucrose as the first ingredient in the hazelnut spread. Sucrose is made up of glucose and fructose, therefore there is glucose in the Nutella Be Ready. Nutella Be Ready wafer contains sugar, which is glucose in this case, and the functional group of glucose is aldehyde group. Aldehyde is a functional group in organic chemistry consisting of a carbon atom double bonded to an oxygen atom and single bonded to a hydrogen atom and an R group. This carbonyl group is always at the end of a molecule bonded to at least one hydrogen atom, to distinguish aldehydes from ketones. Aldehydes are generally more reactive than ketones due to the presence of hydrogen atom on the carbonyl carbon. To make the Nutella Be Ready wafer solution, we need to crush the wafer using a mortar and pestles, as you can see in the video. Then transfer the crushed wafer into a beaker. Then add distilled water to make the solution. Then just keep on mixing it. So the Fellings or Benedict test for aldehyde group is different from ketone. The aldehyde group is exposed in glucose open chain and can participate in redox reactions. In the presence of mild oxidizing agents such as Benedict reagent or Felling solution, glucose reduces the copper to ions to copper 1 oxide, which forms a red or orange precipitate. When an aldehyde is warmed with Benedict reagent, the aldehyde donates electrons that causes the aldehyde to be oxidized and a color change will take place. The solution changes from blue to green to yellow to orange or red depending on the amount of aldehyde present, with the most concentrated solution forming the brick red precipitate. To do the test, first pour 1 cm cube of the Nutella Be Ready wafer solution into a test tube. Here, I use a Benedict reagent to identify the aldehyde group. Add several drops of Benedict reagent into the same test tube, enough to observe a color change. You can see that a green precipitate is formed. Heat the test tube in a water bath for a few minutes while observing the color. After 5 minutes, I pull out the test tube and observe a color change. The green precipitate turns to an orange red precipitate, which shows that an aldehyde group is present. Lastly, some fun facts as additional information. Carboxylic acid is the strongest functional group, and that functional groups are super important in organic chemistry because they decide how a chemical compound will act. They control its physical properties like its melting point and its chemical properties like how it reacts with other substances. That's all from me. Thank you for watching.